In the heart of the medieval Islamic world, centuries before the Industrial Revolution, one man crafted a device that defied the boundaries of time and technology. This is the story of Al-Jazari's water clock, an invention so ahead of its era that modern engineers still marvel at its complexity and elegance. But this isn't just a story about a timepiece. It's the tale of a machine that revolutionized the very foundations of mechanical engineering. I've spent weeks combing through translated manuscripts, decoding diagrams that haven't seen light in centuries, and tracing the intellectual trail of one of history's greatest inventors. And what I uncovered is nothing short of astounding. This video isn't just about an ancient clock. It's about how one man working with brass, wood, and water built the future, gear by gear, drop by drop. Stay with me, because what you're about to hear will challenge everything you thought you knew about the history of engineering. Act 1. A time before clocks ticked. In the city of Diyarbakir, in what is now southeastern Turkey, lived a polymath who would become the Leonardo da Vinci of his time. His name was Ismail Al-Jazari, and for over 2 decades, he served as the chief engineer to the Artukid kings. But Al-Jazari wasn't merely a servant to royalty, he was a visionary. In 1206 CE, near the end of his life, he completed his magnum opus, a manuscript titled The Book of Knowledge of Ingenious Mechanical Devices. In this extraordinary work, he described over 100 mechanical inventions, accompanied by detailed diagrams and step-by-step instructions. It wasn't just a record of his creations, it was a technical manual that bridged art, science, and faith. Among all his inventions, one stands out as both a scientific and artistic masterpiece: his water clocks. Act 2, not just a clock, a universe in motion. To call Al-Jazari's water clock simply a clock is to do it a great disservice. These devices were not only timekeepers but spectacles of engineering, performance, and cosmology. They served religious, scientific, and even diplomatic purposes, combining function and symbolism in one breathtaking structure. Take, for instance, his famous elephant clock. This was no ordinary mechanism. A massive mechanical elephant carried a tower on its back. Inside this tower, hidden from view, was a complex system of siphons, floats, pulleys, and weights, all powered by water. Every half hour, the float would sink as the water drained, triggering a chain reaction. A ball would drop into the mouth of a mechanical falcon, which would tip and release it into a vase below, activating a mechanical scribe and turning the dial of time forward. But beyond the mechanical brilliance, the elephant clock was a celebration of cultural unity. The elephant symbolized India, the dragons represented China, the water technology came from Hellenistic traditions, and the turbaned figure at the top reflected Islamic scholarship. This was an invention that told time and told a story. It was a mechanical embodiment of a global worldview. Now imagine this level of sophistication in the 1200s. With no electricity, no advanced tools, and only basic metals and wood, Al-Jazari achieved what modern engineers might still struggle to replicate with complete authenticity. Act 3. The secret mechanics of genius. So how did he do it? How did Al-Jazari's water clocks actually work? At their core, these clocks functioned through hydraulic power. A reservoir of water would slowly drip into a bowl or container. As the water level changed, it moved a float or weight. This movement would then pull on a rope or chain, which in turn moved gears, levers, or arms. But what makes Al-Jazari's work revolutionary is not just that he built these mechanisms, it's how he refined them. For one, he mastered flow regulation. Through carefully calibrated holes, he ensured that water flowed at a consistent, measurable rate. This precision allowed for the accurate passage of time, a huge advancement over earlier water clocks, which often suffered from inconsistent flow. He also introduced feedback control, an early form of automation. In some designs, when the float reached a certain point, it triggered a system to reset itself or change its behavior. This ability to self-correct and adapt is the bedrock of modern robotics and cybernetics. Then there's his use of the camshaft, a rotating or sliding piece in a mechanical linkage that converts rotary motion into linear motion. Al-Jazari used cams to animate figures in his clocks, producing choreographed movements that could be timed precisely. This feature appears again in modern internal combustion engines and automation lines. His clocks also used differential gears, counterweights, and even programmable automata. That's right, some of his devices could be adjusted to perform different sequences, meaning they were among the earliest examples of programmable machines. Every single part had to be handcrafted, every measurement hand-calculated, and yet the results were machines that behaved like organisms, predictable, rhythmic, and beautifully functional. Act 4. Time as a sacred pulse. But why devote so much time to building these marvels? What was the purpose? In the Islamic world, time was sacred. The 5 daily prayers, Fajr, Dhuhr, Asr, Maghrib, and Isha, had to be observed at specific times. Sundials and the position of celestial bodies were helpful, but not always reliable, especially indoors or in cloudy conditions. The water clock provided an elegant solution. It could be used inside mosques or palaces to mark prayer times with near-perfect precision, even in total darkness. The automation ensured accuracy without constant human oversight, freeing scholars and religious officials for other tasks. Moreover, these clocks were used as diplomatic tools. When envoys from Europe or China visited Islamic courts, they were greeted by these fantastical machines that rang bells, moved figurines, poured drinks, or marked time with animated creatures. These clocks were demonstrations of divine order, of God's presence in human ingenuity. They were metaphors for the universe, ordered, intricate, and governed by unseen laws. Act 5, a legacy carried by gears. After Al-Jazari's death, his influence echoed far beyond the borders of the Islamic world. His book was translated into multiple languages. European thinkers during the Renaissance came into contact with his work, either directly through translations or indirectly via the influx of Islamic knowledge into Europe through Spain and Sicily. Many of the core mechanical principles that Al-Jazari pioneered would later appear in the works of Leonardo da Vinci, who designed machines based on similar hydraulics and cams. Whether directly or indirectly, Al-Jazari's innovations seeped into the bloodstream of global science and engineering. In the modern age, historians of science and mechanical engineers alike are re-examining his works. Roboticists are building working models of his automata. Universities are teaching his principles. Museums across the Middle East and Europe feature reconstructions of his clocks. Yet outside of academic circles, his name remains largely unknown, and that is perhaps the greatest tragedy. Act 6. Rediscovering the man who made time move. Today, we live in an age ruled by time. Our lives are scheduled to the second, tracked by atomic clocks, smartwatches, and satellites. And yet, few of us know the name of the man who helped make all this possible. Al-Jazari's water clock is more than an invention. It is a statement, a testament to what human ingenuity can achieve when science, art, and spirituality converge. It tells us that innovation didn't begin in modern factories or Silicon Valley, but in the workshops of scholars, scribes, and engineers who saw the world as a machine built by a divine hand and dared to replicate its harmony. So next time you glance at your watch or hear a clock chime, remember the man who harnessed water to capture the rhythm of time, not with electricity, but with pure, flowing brilliance. Thank you for watching. If this journey through time and engineering inspired you, consider liking and subscribing. More stories of hidden genius and ancient technology are coming soon. But for now, remember, every drop of water, every ticking gear, owes a little something to a man who lived 800 years ago, and still shapes the way we measure our lives today. Make sure to like this video, subscribe if you want more untold stories like this one, and leave a comment below. We'd love to hear your thoughts. We have more videos on Islamic Golden Age scientists who changed the world. Click the playlist on the screen for more content.